We're going to continue our learning about evaluating functions, but in this video we're going to focus on evaluating things called piecewise functions. A piecewise function is a function that's broken up into pieces. And the function rule that's applied to the input changes depending on what that input value is. So oftentimes piecewise functions look like what you see in the box, okay? We have the original name of the function and the input values again, but you'll see that this function is actually broken up into three pieces. So piece number 1, piece number 2, and piece number 3. Okay, so we have function f that's broken up into three pieces. And in this kind of notation, what comes directly after this tells you what the rule is, right? What's going to happen to the input value. But right after the rule, it tells you which input values that rule is being applied to, right? So for the first, you can see for the orange part, or the orange piece of the function, that rule of f of x equals x is only going to get applied to input values that are less than -3. And the second piece is only going to get applied to the input values that are between and including -3 and 4. And the last piece, that rule is only going to be applied to input values that are greater than 4. So it does add a little bit of complexity because first, as we're evaluating these, we need to figure out, well, which piece of this piecewise function does the input value that's given belong? So here's what I mean by that. Let's consider the piecewise function I have up above, f of x. What is f of -5? All right, so I'm telling you that the input value is -5. So we need to figure out which piece of this function does -5 is a part of the domain, -5 part of its domain. So is -5 less than -3? Yes. Yes, it is, right? So -5 is going to fall into that piece of the function. So we're going to use f of x equals x. And remember that if -5 is the input value, then f of -5, we replace all the x's with -5, and we get f of -5 equals -5. So basically, this function, this piece of the function says that f of x equals x. It means, well, whatever the input value is, the output value is going to be the exact same thing. So if the input's -5, the output is -5. So which piece of the function has the domain which includes -5? Well, it's the piece that's f of x equals x. What about the next question? What is f of -3? What piece does that go to, and how do you know? Does it go into the first one, or does it go into the second one? Well, this is where our knowledge of inequalities comes in handy. In the first piece of the function, x has to be less than -3, but in the second piece of the function, x is greater than or equal to -3. So if the input is -3, then it's equal to -3, and we have to use the second piece of our function, f of x equals x squared. And how do we know? Because of the inequality symbol. Because of the inequality symbol. And so what exactly is f of -3? Well, f of -3 would be -3 squared, and -3 squared is -3 times -3, which is 9. So f of -3 is equal to 9. That is what piecewise functions look like algebraically, but graphically they kind of look like this, right? You see how this graph is broken up into different parts? We have like piece number 1, we have piece number 2, and we have piece number 3. So it's up to us to decide which piece of the function, which piece of this graph the input value belongs, paying very close attention to the fact that we have these open circles on our piecewise function. So let's take a look at this. What is f of 1? F of 1. So remember, the 1 is in parentheses, so this is our x value. Okay, so we're going to go to 1 on the x-axis, and I'll do this in red. We're going to go to 1 on the x-axis, and we're going to go all the way up like this. Okay, so any point on that line there is going to have an output, the input value is -1. But you'll notice that there's 2 points. There's a point that's closed, and there's a point that's open. Remember that the open circle means that there's not actually a point there, right? That point does not exist. So really, it's just the closed circle point that we are going to consider in this case. And so when x is equal to 1, what is the output? Well, the output is equal to 1 as well. So f of 1 is equal to 1. This is how you evaluate piecewise functions. Whether it's written algebraically or it's shown graphically, you need to first figure out which piece of the function that the input value belongs, and then you evaluate just that piece. Or if it's written graphically, you need to remember that any open circles on a piecewise function are points that do not exist. Closed circles do exist. So at this point, I just want you to take a second and rate your progress on the learning target. I can evaluate functions in different forms, such as a graph, including piecewise, a table, ordered pairs, a rule, etc.